Alright, quick explanation on how brakes and anti-skid work on the C-5. If you look here, hydraulic system number 4 pressure is going to be our normal means of getting hydraulic pressure to our metering valve and to work our brakes and anti-skid. Over here, hydraulic system 1 is going to be our alternate means to get pressure to work anti-skid and brakes. And our accumulator up here is going to be our emergency. So following this, we have normal system pressure making its way in here and overcomes a check valve and charges up our accumulator. So right now we're working with the brake select switch in normal, and the way that's going to work is in normal it is going to energize our alternate and our emergency means for hydraulic pressure closed. And so right here, this valve is going to be energized, closed, and it's going to port to return. Over here, our emergency is going to be closed and ported to return. And our normal right here, kind of in the drawn position, I guess I should say that this schematic is drawn basically with brakes applied, hydraulic or normal hydraulic pressure available, and brakes applied. So like I said, it's going to be de-energized, open, allowing hydraulic fluid to make its way through the valve, out, overcoming this weird looking shuttle valve and through to our pilot metering valve. And right here is a tap off for our transmitter that'll tell us how much pressure that we have. So with normal system available, we have, I just showed you how fluid gets to the pilot metering valve, but we also have right over here this pressure coming down here, and what this pressure does is it allows pressure to push against our four-way selector valve. And when it pushes against our four-way selector valve on the bottom end, it's going to overcome the spring tension, spring tension that's on the top, and it's going to move and kind of shuttle it upwards, kind of the way it's drawn. So with the pressure sitting down here, it's going to move it upwards. And what that does is when the pilot is going to mash down on the brakes, through here, through the metering valve, it allows pressure to make its way through here, meter pressure, go through our four-way selector valve, come through, all the way across here. And right here we have a tap off, and the same thing's going to happen with pressure applied to the bottom side. It's going to move our fluid system selector valve upwards, which then is going to allow hydraulic fluid to kind of go through it, up through here. And the first place I want to draw this out to is going to be all the way over to our parking brake selector valve. So it makes its way to our parking brake selector valve, this side, and it does basically the same thing where it applies pressure to this side of the parking brake selector valve, and it pushes it over, closing off. If you notice these little tap offs right here, which will come into play later, but it closes these off and allows these ones to be opened up right here. But I'll get back to that. So if we kind of go back a little bit, so with hydraulic fluid that made it through our fluid system selector valve, we're going to have hydraulic fluid and hydraulic pressure coming through here, kind of filling this entire area. We've got some snubbers in here. And this tap off right here is going to do the same thing with that pilot meter pressure. It's going to apply pressure to this side of our main metering valve, shifting it over, and as it shifts it over, you can see another port is blocked off right in here. And talk about that again in a second. So pressure comes in through here, over, and all the way up to our anti-skid kind of torque motors. And then if we kind of fill the rest of this in, we've got pressure coming through here. Now, with that being done and the pilot mashing on the brakes, and it shifts our main metering valve over to the right through here, kind of this delta note number 5, we're going to have hydraulic pressure from system number 1, or I'm sorry, system number 4, coming through here through a non-bypassable filter, and it allows this hydraulic fluid to make its way up and through this entire kind of manifold through here and down. Now with that metered pressure that the pilot put in, that's going to, depending on how much pressure you put on the pedals, that's going to allow a certain amount of fluid to make its way through and down, all the way down to our parking brake selector valve, which has been shifted over to the left. It'll make its way through some fuses, through some pressure switches, and it'll make its way all the way down to the brake pairs. And that's going to be kind of the same for each one of the main metering valves as it allows pressure to go through. And so at that point it will apply the brakes. Now, so I don't have to draw out all of these, I'll just do a quick little, makes its way through each set of brakes, just kind of follow the diagram along and you'll see where it goes to each set of brakes. Now, if by chance one of these brakes were skidding, so let's say right here, the 2 Charlie 2, it got locked up and it was skidding, so that would be sensed. If you kind of follow, let me change the color real quick. Let's see. If you follow this right here, these are kind of like the tap-offs, and it'll send a signal all the way to your anti-skid control box right here. Now when your anti-skid control box gets a signal that brakes are locked up, what it ends up doing is it sends a signal all the way up to the associated torque motors. If you kind of follow these wires all the way up, and it will adjust the positioning of the torque motors to, if you can imagine it, let me change it again, the torque motors will then shift over and will allow pressure if it needs, because it'll cut off pressure, not completely, but it just kind of depends on what the anti-skid control box feels it needs to be done. But so it'll allow more pressure, or hydraulic pressure to come through, and it'll port it to return if you follow that all the way through. And what that does is it changes the positioning of the main metering valve. So what will end up happening is at that point, because it's porting more pressure off to return, now there won't be as much pressure on the left hand side, but there will be more on the right hand side, and you'll have more pressure pushing along with the spring tension, or the spring that's in there, and it'll push this entire main metering valve over. And what that'll end up doing is closing this off a little bit in here. Not completely, but it'll close it off, allowing less fluid to make it past the main metering valve and down to that brake. I kind of drew it, if you can see it, on the center main metering valve. I kind of tried to make it so you could see it. It's how this port right here is kind of closed off in there, which would allow less fluid to come through. That way you can kind of get a visual depiction of it. Alright, now I'm going to talk about alternate brakes. So let me get rid of all of this. So with alternate brakes, it's pretty much the same thing, except you don't have fluid going through your four-way selector valve. So over here you're going to end up selecting alternate for your alternate brakes. Once that's done, you're going to have your valve for your alternate brakes. It's going to be opened up, de-energized open, I should say, and your emergency is going to be kind of cut out of the picture. It's going to be energized closed, and then your normal is going to be energized closed. And so what's going to end up happening is, if you can see here, hydraulic system 1 pressure, so hydraulic 1 being your alternate brakes, you're going to have pressure coming down through all the way to your pilot metering valve, and then depending on how much the pilot will mash on the brakes, the meter pressure will make its way through and over. If you kind of follow this over, and the difference here is going to be, as it sits right there, you're going to have pressure making its way, you can kind of see these little lines, to the top side of your fluid system selector valve, and then it's going to end up pushing down on the top side of your fluid system selector valve, which then would shift the entire valve over, and then it would, if you can imagine it, it would be kind of locked down into this detent here. So all of these areas would come down just a quarter of an inch, if you can imagine it. So then what that does is right here, this delta note number 4, it will allow normal pressure to make its way through, and in the same way that we had normal system pressure pressurizing these lines, we're going to end up having alternate system pressure pressuring these lines. And then, let's see, let me back up a second. Also through here, as the valve shifted, we're going to end up with pressure being allowed to make its way through here, which then is also going to apply, like before, that pressure on the left hand side, shifting our main metering valve over, which then will, as you follow this around, apply pressure, it'll be able to make its way all the way to the torque motor, and then these tap-offs right here will allow pressure to make its way through all the way down to the brakes. You kind of trace it all the way over and out. So same kind of thing. If you end up with an anti-skid, it's going to do the same thing. It'll, shift over our torque motor, allowing fluid to be ported to return. It'll make its way over and through, return, eliminating the skid condition. Alright, now I'm going to try to explain emergency. In emergency, it's basically done all up here by this accumulator that's drawn there. Now, same thing as before, we're going to take the switch to emergency. Our normal is going to be energized closed. Our alternate is going to be energized closed. And then our emergency is going to shift over, and it's going to be de-energized open, allowing hydraulic fluid to make its way over, push over the shuttle valve, make its way to the pilot metering valve, and if he presses down on the brakes, we're going to have meter pressure being able to make its way down. Now, because we don't have that pressure on the bottom side that we used to, at that point we're going to end up with this spring shifting the valve down. So this tap off right here is going to be closed off. And so the pressure, if you can imagine the valve shifting down and filling in this yellow space down here, then we're going to have a pathway to make its way through, down through a fusible plug, all the way over, and it's going to make its way all the way through our parking brake selector valve. The first tap off right here is going to allow it to apply pressure to this side of the parking brake selector valve, basically shifting it over. And when that's done, these tap offs right here are going to be closed off. So these right here, they're going to be closed off. If you can imagine this T thing coming over, and then these ones right here at that point are going to be opened up. Choose different color. So these ones right here that are kind of hidden, they're going to be opened up, allowing hydraulic fluid to make its way through, down, into each set of brakes to stop the plane. So same thing over here, you can see this tap off, down and over and through, and this one right here too, down, over, and through. Alright, so lastly I'm going to try to explain this anti-rotation side of this schematic. So after we take off, we can hit the brakes, and having 3,000 psi kind of hit the brakes, it wouldn't be a good thing. So we kind of have this anti-rotation side. So what ends up happening is after we take off, you can see here that this gear linkage right in here, it will actually, as the gear or strut extends, it'll move in that direction. And what that does, it lines these ports up. If you can imagine those ports, they'll be lined up kind of like this. And that's the brake pressure that we'll get. It's a reduced pressure. So how that happens is over here, our wheel spin up detector unit. So after we take off, the strut's going to extend. It'll detect wheel spin up from these wheels. So 3 alpha 1, 1 alpha 2, 2 alpha 1, 4 alpha 2. And if it detects it, oh, I forgot this little detail right here. So gear handle will be up, and so it'll make that contact to our valve. So then, if it does detect it at that point, the wheel spin up detector unit will send power, or energize this relay, or send power to energize the relay, pulling the contact down, allowing power to flow through, over, all the way to our valve. And I try to look up the name of the valve, but basically they just called it a three-way selector valve. And so it'll shift over our valve, and what that does is it allows system number 4 pressure at that point to make its way through, let's see, through here. So system number 4 pressure down through, it'll shift it over, and it'll go through this pressure reducer all the way down, shift over this shuttle valve, come down, and you can see right through here, it even calls it our in-flight brake line. And so through another fuse here, and like I said, through those ports, it'll make its way over and allow pressure to go to our brakes. But like I said, it's going to be a reduced pressure. I couldn't find any exact pressure associated with it. I think in class they said it was like 300 to 400 psi as opposed to a full potential 3,000 psi. Thanks for watching.